Hey everyone, welcome to a very special edition of Hypermode Live. My name is Will from Hypermode, and today we have special guest joining us from Germany, Michael Hunger from Neo4j. Hi, Michael.
Hello, everyone.
Hello, Michael.
Good to see you all.
And joining us from sunny San Francisco, we have Raphael, also my colleague at Hypermode. Hi, Raphael.
Hi, everyone. Exciting to talk about graph things today in Hypermode. So, Will, what's the menu?
I have something playing in the background. So give me like 1 second to figure out where that is. That is super distracting. Sorry about that. All right, 1 second here, folks.
And Michael, I've seen you prepared your background with some
yes, I have lots of
graph things and
graph algorithms books and graph databases books and our DuckDB book that we just published as well.
Perfect. So we are ready for digging into the details of the graph and
exactly octopus and lots of other graph stuff as such, right? So it's been some time, so 15 years of working in graphs and using graphs for more than 25 now. So it's been quite a journey. And Will actually was part of that. So Will and I, we worked together for a long time and had lots of fun working together at Neo4j.
And it's a cool
and
ecosystem.
Now I'm happy.
Yes. And I've also
it's a great
the graph algorithm.
Awesome.
and
we can have joint book. Will, where's yours?
And I spent years playing with Dgraph and also a bit Neo and Neptune and the different languages and gremlins. And so that's also interesting to see how we can leverage that in the new AI world now. So as soon as everything aligned, we'll dig into this.
Yeah, and I think kind of given that the LLMs are good at language, but they lack memory and they lack complex memory, graphs are a really good companion to LLMs, right? So where they basically provide like all the memory and all the contextual information to what the LLMs are missing. And so we can combine the power of graphs with the language skills of the LLMs, and then we get the best out of both worlds.
Yep.
For sure. Yeah, sorry about that. I had the video playing on delay in the background, so found that, so we're all good to go. Cool. Yeah, so we have a lot to talk about today with knowledge graphs and AI, so I'll try to keep us on track here. This is the rough outline for what we want to talk about. We're going to talk a bit about the Knowledge Graph and AI Challenge, which is a hackathon that Hypermode and Neo4j just launched this week. So this is kind of a fun running through the end of the year hackathon. We have a $10,000 prize pool.
Nice.
So we'll talk about this and some resources for getting started. And then I want to take a look at some hands-on examples using Neo4j with Modus. So Modus is the open source framework for building model native apps. And we recently added native support for Neo4j. So we'll take a look at using Neo4j with Modus. Michael's going to give us a bit of context for that one and give us an intro to Neo4j. And then Raphael is going to give us a demonstration of using Dgraph with Modus with a GraphRAG example. And then we'll leave plenty of time for Q&A and discussion. So feel free to drop any questions you have in the chat. We're monitoring that. We'll try to make this as live and interactive as possible. So feel free to drop any questions in the chat. I can see them on my other screen here. We'll get to those. Maybe just to make sure we have the chat working, if everyone just wants to let us know where you're joining from today. It's always really cool to see folks joining from all over the world. And so with that, let's get into it. So at Hypermode, we build and maintain open source projects for what we say building model native apps, right? We think that the future of software development will involve models used by software developers in their apps to some degree, and we build and maintain open source tooling that enables that. One of those projects is Modus, which is a serverless framework that allows you to write functions and think in abstractions of functions, data, and models. We use WebAssembly to take functions that you've written in different languages. Currently, we support AssemblyScript and Go. We compile that to WebAssembly so that when you then invoke those functions through a generated GraphQL API, that you have sandboxed memory invocation for sort of secure and super efficient code. So these are kind of the components of Modus. Matt, in a previous Hypermode Live episode, did a deep dive of this. Modus Deep Dive, I guess, was the name of that. We'll link that in the description if you want to dig in deeper into Modus and how it works. But the important part that we're going to talk about today is over here. So on the production side of things in the Modus runtime. So I said that the abstractions that you have when working with Modus are functions. You write functions. Those are turned into endpoints in a generated GraphQL API. You have models, so AI models, and you have data. And so it's really important, of course, that your models and your apps have access to data from databases, other APIs. This is where knowledge graphs like Neo4j and Dgraph come in. So in Modus, we're adding support for multiple data sources. Currently, we support things like HTTP APIs, GraphQL APIs, Postgres, Dgraph, and now Neo4j. We're adding lots of other data source support going forward as well. So let us know if there are other tools or integrations that you'd like to see. But it's really important to be able to access data in your app, of course. And let's talk about knowledge graphs specifically and why they're relevant for AI. So we said that with Modus, we want to enable you to build model native apps, so applications that are leveraging an AI model or more. And these are sort of the building blocks that I see for building these model native apps with Modus. So first of all, being able to chain together data and your LLM calls. So can you fetch data from an internal database and then chain the results as context to a prompt in your LLM? And then the next step is implementing function calling or tool use. And this is where you define tools or different data sources, different actions that the model can take, and you let the model decide sort of which is the best control flow, which is the best data source to fetch based on sort of the task that at hand. And then the last one, which we're going to dive into deeper today, is this idea of knowledge graph RAG, or leveraging a knowledge graph in the retrieval augmented generation flow, which we'll dive into a bit deeper today. So whether we're talking about knowledge graphs in Neo4j or Dgraph, so I should say Dgraph is an open source graph database maintained by Hypermode, and Neo4j is another very popular open source graph database. And I think it's really important to be able to work with the data and tooling that you're familiar with in your app, which is why we're adding support for Neo4j and Modus. So easiest way to get started with Modus, which we'll take a look at in a minute, is by installing the Modus CLI. But before we do that, I want to take a look at the Knowledge Graph and AI Hackathon that we kicked off earlier this week. So this is the link. Let me drop this link in the chat. To be sure to join if you're interested. There we go. Drop the link to that in the chat. So this is a hackathon on the DevPost platform. You can just sign in and create an account on DevPost to join. We currently have, looks like 104 folks that have joined. We launched just yesterday. And so this runs through January 12th. So we wanted to have kind of a fun end of the year challenge. And really, I'll let you folks read through this, but really the goal here is to build a model native app. So some project that uses Modus, which you can think of as your sort of coordination layer for working with AI models and different data sources, and make use of at least one AI model and a knowledge graph. So we have starter code, and we're going to talk about today using Dgraph and Neo4j. But of course, we leave the specific implementation up to you. Some guidelines. So share your project on GitHub. We'll be looking through the code to sort of see the complexity of what you built. Here's some ideas for the type of things you can build. It can be a complete web application, or you could just leverage the GraphQL API in a Modus app. But you can sort of see the different prize categories to get an idea of what the judges will be looking for. So in addition to kind of a top 3 overall, we have special categories for the best use of Dgraph, the best use of Neo4j, best agentic app, the best use of knowledge GraphRAG as well. And we can see here that Michael, Raphael, and I are some of the judges here. So if you have any questions about this, join our Discord. There's a link to the Discord up here when you sign in DevPost, and we'll definitely be happy to give you feedback on your project ideas or sort of answer questions about code, how to implement things. So definitely feel free to get involved with us there. I'm curious, Michael, Raph, if you weren't a judge and you were participating in this hackathon, I'm curious, what kind of project would you want to build for the hackathon?
Yeah, so there are 2 parts I'm really interested in. And when we talk about the knowledge graph, is building a knowledge graph and using a knowledge graph. So it's interesting to me how people will investigate those 2 directions. There is a challenge in building a knowledge graph and maintaining a knowledge graph. And I see that AI and LLM can really do a good job in, auto extracting entities, trying to find, relationship into a text and organizing the knowledge to craft and build a knowledge graph. And maintain also the relations and to see that, oh, a new entity appears, it's similar to this one, and we need to group it or whatsoever. And the second part is, when I have this access to a knowledge graph, how can I leverage this knowledge to something meaningful for end user? So that's my 2 big ideas. I have no specific things. I'm really curious to see, it's part of the innovation. Last time at the hackathon, we had also surprises in terms of where people are going. So I don't want to give any directions, but that's my 2 topics that I have in mind at the moment.
Cool. Yeah, we earlier in the year ran a Modus hackathon with the folks at Hashnode, and left that very open-ended. And you're right, it was really interesting to see some of the things that people built. That was that was a super cool one. So it's fun to leave things a bit open-ended and challenge people's creativity. But to inspire folks, maybe, what about you, Michael, if you were building a project for this hackathon?
That's a good question. So I spent the last 2 years working a lot on knowledge graph creation and busy building chatbots and so on. So I was wondering, actually, another topic that could be interesting, if you look at a PKM space, like personal knowledge management, like think Roman, Obsidian, and so on, can we basically augment this with, some smarter, both connecting the data, but also interacting with the data, right? Lots of people take markdown nodes in Obsidian or in Rome that are connected behind the scenes into a graph. But I think today there's not so much done with the text part of it. And so that could be an interesting one where you basically turn the text chunks into embeddings, and then you get basically easier access to your external brain, to say so, right? And can we actually identify links that are missing between these documents and basically find an easier way to chat with this, and perhaps even turn it into an, voice interface where you can talk to your notes and research notes and other things, perhaps on your phone by audio mode or something like that. That could be interesting. So I'm not sure if in Modus you can currently do audio in and out streaming, or if you have to put something in between in front of it. But that could be an interesting one on top of that.
Cool. Yeah, that sounds like fun. Great. Well, let's dive in, and maybe to kick us off today, Michael, maybe you could kind of walk us through Neo4j and give us kind of a overview and intro to Neo4j.
Yeah, totally happy to do that. I've been doing this for quite some time. So as I mentioned in the beginning, when we were talking, the graph, so LLMs and knowledge graphs actually go well together, right? So because the LLMs bring the language skills, and the knowledge graph brings the data and the connected information as such, right? So, and if you talk about graphs in general, it's basically entities with attributes connected to other entities with attributes, right? Just as a really quick basic thing. And Neo4j has been around for by now 15 years. So I joined early on 15 years ago, and we've been building a lot of tooling. You can use Neo4j on your desktop. You can use it in Neo4j Sandbox, like will show. We have also a cloud service called Neo4j Aura that basically runs Neo4j, and there's a lot of tooling around it. So there's tooling to query the database. So for instance, here we can, this is a graph of a bunch of documents. So I used another tool that we built this year called a Knowledge Graph Builder, where you can upload PDF files or Wikipedia pages or web pages or YouTube videos. You can define a graph model here like this. I have company, technology, person, location, and then a bunch of relationships. And then I can select a few models to basically extract entities out of these chunks. And then I can take any of those. Let's see if we take, for instance, here the Google DeepMind AlphaFold blog post, and look at the extracted nodes and relationships. So you have basically the document with the chunks. And then here you have some of the extracted entities. Sorry, wrong way. So some of the extracted entities as well, right? And then if you want to see this, so this is kind of separate, but if you want to see this in the Neo4j tooling, I can, for instance, say, show me all the documents in this graph. So I see the 5 documents, and I can basically double click them and expand from there, or go further here. And of course, I can do grouping, aggregation, filtering, and all the other things with Cypher widgets. You can think about it as SQL for graphs in a way, right? So that's part of the tooling. The other tooling that we have is more for a non-developer audience. That's kind of, it's called Neo4j Bloom. And here you can basically express, let me clear this out. You can express basically your queries in patterns, where I can say a document is connected to a chunk, for instance, here, and then a chunk is connected to an entity. And then we can basically just run this query, and then it basically fetches all the documents with all the chunks and renders this as such. It also supports spatial rendering and other things. And then I can basically go from here and filter things by time slices or other things. So there's lots of ways of how I can basically work on this. For instance, I can take one of these attributes and then slice over that as well. And then, of course, there's database import, where I can import data from files, but also from relational database sources, and then do graph modeling on top of this to map my data to the graph. And so all this tooling is available to you. You can use it for free. We have also, of course, drivers like the one that has been used in Modus to integrate with Neo4j. It uses the Go driver under the hood, and basically all these drivers basically work by connecting to Neo4j and then basically executing queries, and then you get results back that you can then process however you want as such. And to look a little bit deeper of what's possible, we put together like a page that gives you like details, options, frameworks, and so on. So obviously we have to add Modus now as a new framework that just came out last week. And this is something where we collect all our integration and features around GenAI for Neo4j, but also a lot of other tooling, as you can see here on the site as well. And the last thing that I wanted to show is this site. So we created a site where we collect patterns around GraphRAG, because I'm a big fan of patterns myself, right? So I have a lot of pattern books here besides me. But I think it's important to find language and capture common patterns as such. And so many of these GraphRAG patterns are basically based on a certain domain or a certain shape of the graph. So this is, for instance, a domain graph. We also have a lexical graph with extracted entities. So we have documents, chunks, and entities. We have also hierarchical graphs that have basically hierarchical structures and so on. And then on top of these graphs, you can run different retrievers. So for instance, there's like graph enhanced vector search, where you use this graph shape as a basic graph, and then you do a pattern search where you basically find elements that are part of a document, and then with each of those nodes, you fetch our entities to get the data back. And this is then fed to the LLM, as you can. Do we have it? GraphRAG. As you can see here, basically, so the data that comes back from the graph is then fed to the LLM to generate the answer. And if you want to have an agentic approach, then of course this can be tool calls that run multiple times as well. And so a knowledge graph builder, what you can then do is basically use a number of number of retrievers, like vector retriever, graph, vector, full text. And then I already ran the query here, where you can switch between the different retrievers and see the different results that come back, and then basically see in details which sources have been used for answering this question, which chunks went into the answering the question, what are their scores as well, but then also see which entities actually went into answering this question. So that's where the explainability aspect of GraphRAG comes into play, right? So not just basically seeing what was responded, but where did it also come from, and then you can basically drill down and see individual entities that have been used, or you can basically see all the entities that went into answering this question as well. And then here we also added eval metrics, where we can basically then use RAGAs to compute a bunch of metrics for the different retrievers that we have here as such. So, and this is all open source, so you can also have a look at it and see how this works behind the scenes, and so you see basically what models are used and how this is working. And all the data basically ends up in a graph, as I showed you before. So you can basically then build any kind of application on top of that. So you can basically use, for instance, Modus to build a mobile app that then makes use of the graph and combines it with an LLM as such on top of the GraphQL API that your functions are turned into as such.
Cool.
So that was a really quick
awesome.
run through. Really quick run through everything. And if you want to see more, feel free to go to the GenAI ecosystem page here, and that has a lot of links to all the different pieces and parts that you can find in this regard.
Cool.
Okay, that's me.
I was sharing some links in the chat as you're going through that, so hopefully I caught most of the resources there. If you want to see what Michael is sharing, that's great. Let's take a look at building a Modus app with Neo4j. Michael, what would you say is the easiest way to get started with Neo4j?
We lost Michael.
Sorry, I accidentally turned you off instead of your screen. Sorry about that.
So there are two ways. So one is Neo4j Aura that you can basically connect to, and then basically see all your manage and see all your instances. There's free instances that you can create and use there, and other layer tiers as well. And for a number of example data sets and quick getting started, you can also go to sandbox.neo4j.com and create your instance there. So these are free trial instances, so they go away after 3 days, and then you can basically use a bunch of existing example data sets as well for this. So it's up to you, either free trial 3 to 10 days, or perpetual free instance on ORDB, or then basically the paid tier, the other instances.
Cool. I shared a link to Neo4j Sandbox in the chat, and that's what we're going to use today. So I created a Neo4j Sandbox instance just by signing in. When you first sign in, you get this screen that has a whole bunch of different data sets. I chose the recommendations data set, which is movies and user reviews of movies. So you can see here we have our Neo4j instance up and running. If I click on connection details, I can see the connection credentials, which we're going to need in a minute to connect to our Modus app. But here's Neo4j browser. We can take a look at the basic functionality here as we write Cypher queries, and then we have a little graph visualization of the results. But we can see the data we have here. So we have movies. Movies have like a budget, country they were released in. They have an ID, a plot, a poster image, these sorts of things. And then movies are in a genre. We also have the actors and reviews. So here's a user who rated Toy Story. She gave it a 5-star review. That's stored as a property on the relationship here. So that's the basic structure. What I want to show is building a Modus app that, first of all, generates embeddings. So we're going to take the plot, this text here, the description of the movie, and we're going to generate embeddings and then use Neo4j's vector search to find similar movies. And we're going to do that in a Modus app. So we'll have a nice GraphQL API that exposes this functionality. Michael, do you want to say a little bit about what an embedding is and
Yes,
how vector search works in that context?
Yeah, exactly. Yeah, happy to do that. So embeddings are basically vectors, means numerical or arrays of numerical values, floating point values that represent kind of the essence of something, right? So they are used or generated by embedding models, which are a form of machine learning models where basically the last layer of the model, like all the weights that come out of the last layer, are turned into a result vector, and this result vector represents kind of the essence of the input, right? So, and that essence can be from text, from audio, from video, from images as well. And then if you compare vectors in the multidimensional space, so there are vectors with 384, 1536 dimensions, 7086 dimensions, and other depending on the embedding model. And if you compare to vectors, then you actually, it turns out that vectors that are close in the embedding space, so either by angular distance, which is cosine similarity, or by the Euclidean distance, which is the actual like Pythagoras distance, basically, they are also close in semantic meaning, right? So if you basically say, okay, I have the embedding of New York and I want to find other cities that are closest in embedding space, then I would probably find London, because it's also a large city which is a financial center as well, right? So, and then you can basically do operations on these vectors, but mostly it's used actually for similarity search. So basically allows us, sloppy humans to type in any arbitrary text. We don't need to look at spelling or correctness or anything, and then it finds the closest vectors that are closest to the input in the space. So basically the input is taken also to an embedding model, generate an embedding, and then with my search vector I find nearest neighbors. And I can do this in brute force, basically where I go through all the vectors that are in the database and compare each of them. But nowadays, most vector search indexes and databases use an approximate nearest neighbor approach, where you use, for instance, a graph model to find a k-nearest neighbor graph that is then represented in the vector search layer. And you find the nearest neighbors to that input vector and return them to the user. And that's usually exposed in databases through functions or similar means as such. And quite a nice companion, I would say, to all the other types of indexes, from full text search, spatial search, range search, and other searches as well.
Cool. And that's exactly what we're going to do in a minute here. We're going to use an AI model through Modus, hosted by Hypermode, to create embeddings for each of our movies based on the plot. We're going to then write that embedding back as a property value to Neo4j. We're going to create a vector index in Neo4j, and then use Neo4j's vector search functionality to find similar movies based on the embedding. So let's take a look at how we get started with Modus, and then we'll connect that to our Neo4j instance. Dropping a link here to the GitHub repo for Modus. So Modus is an open source project. We can install it, npmi-g Hypermode Modus CLI, I think. This is how we can install the Modus CLI. The CLI is the best way to get started with Modus, and then I can type Modus new. And this is going to walk me through kind of a getting started process for skeleting out my Modus app. So currently, Modus supports Go and assembly script. Assembly script is kind of like TypeScript, similar enough that I think if you're familiar with TypeScript, it should be pretty familiar. We'll pick a name for our
Even
app.
I could get stuff working, and I'm not a super strong JavaScript or TypeScript developer, so
there we
it's
go.
good enough for me.
A great endorsement for assembly script there. So this is going to create a skeleton for our app. We can see here the important files are going to be, not node modules. Important files here are going to be modus.json, which is our app manifest, where we declare our data connections, the models we want to use, these sorts of things. And then also, in this case, index.ts, which is our assembly script file. We have a very basic hello world example that is just a single function, say hello, that takes a optional string argument and then says hello world. So let's run this. We'll say modus dev. Let me get in the correct directory. We'll say modus dev. So you want to be in the directory that has your Modus JSON file. And we can see here that our function, there's one function found, say hello. Our GraphQL endpoint is now ready at localhost 8686/GraphQL, or we can use this explorer at localhost 8686/explorer. So this is API Explorer that shows us our functions, how they map to queries and mutations in GraphQL. In this case, we can see we have one single query, say hello. We can run this. It says hello world. We can input our optional arguments. Now it says hello Will. Cool. So that's the basic getting started process for Modus. I'm going to switch over to an app that I wrote earlier this morning. And this is connected to my Neo4j sandbox instance. So let's take a look at our Modus JSON. So I added, let me make this a bit bigger. That's probably quite small. So I added a model here. This is the mini LM embedding model, comes from Hugging Face, but hosted on Hypermode. So one thing that's nice with using Modus, you can connect to like OpenAI, Anthropic model providers with an API key, or you can also leverage some of the shared models that we host on Hypermode infrastructure for free. You just need to connect with another CLI. So we do npmi-g Hypermode hype CLI. And this is the Hypermode CLI, which allows you to connect your project to Hypermode for things like deployment or accessing those shared models. I just ran hype login, which will prompt you to sign up for Hypermode. You can sign up with GitHub or something like that. I'm already logged in. So I just need to select my organization. And now I can leverage those shared models on Hypermode. The other connection I added is a connection to Neo4j. Here I've put in my credentials for that Neo4j sandbox instance. So now if I go to my index.ts file, we can see that I've added some functions here. So this first one is generate embeddings, which takes an array of strings and returns an array of vectors, so an array of embeddings. And it grabs our mini LM embedding model invokes it on the text that have passed in and just returns those. So let's do a Modus dev and switch over to our, I have it running here, to our API Explorer. Make that a bit bigger. There we go. And this is generate embeddings. So you can see here that this function that we defined in assembly script gets mapped to a query field in the generated GraphQL API. And so let's just put in, imagine this is a movie plot description. If we run this, this will generate an embedding using the mini LM model hosted on Hypermode for my array of text, which is just this one. So here's that embedding that we can see. So we're going to use this as kind of a helper function to get embeddings for movies. This is our get embeddings for movies, which just takes an array of movies. I've defined some classes here. I have a movie class that has a title, plot, rating, ID, and an embedding. And then a movie result also, which is going to be the result from our similarity search. The difference is this has a movie and a score attached to it. So those are the classes I've defined. So you can see here this get embeddings for movies function. This is just going to take an array of movies and call this generate embeddings with the plot, and then add the embedding to those movies and then return them. But this is the function I want to run first, which is save embeddings to Neo4j. So I've defined a cipher query here. We're going to match on our movies. I'm ordering these by IMDb rating. So we're getting the 100 top rated movies out of the database. We're creating an array of movie objects, and then we're passing that to our get embeddings for movies function, which is going to use that mini LM embedding function to generate embeddings. And then we execute another cipher query that's just going to go look up those movies by ID and set the embedding property. And then we create a vector index so that we can then leverage that for vector search. So let's go ahead and run that. Save embeddings to Neo4j, and you can see that this is a mutation. There's a convention in Modus that looks at the name of your function. So if it's like get, find, that sort of thing, we identify that as a query. If it's like save, create, that sort of thing, we identify that as a mutation. So just a nice convention there. So I'm running this. We're going to generate embeddings for our top 100 movies. And then here we can see those were returned. So if we go back to Neo4j browser, and now let's find movie title, Band of Brothers, I think was one that I saw there. Now, if we look at this, we can see, cool, now we have this embedding that's stored as a property on our movie. So we've updated our data in Neo4j, and now we're ready to search for similar movies. So we have another function, find similar movies, that we've defined here. This takes a title and a number. We create Neo4j variables, so because we're going to have these passed to a parameterized cipher query. And so we're going to look up a movie by title. So the way this works is we're going to pass in a title of like our favorite movie or the movie we're watching. Think of this as like powering a recommendation feature. So we're going to start from an existing movie, and then we're going to use the vector search functionality in Neo4j using our movie index, which we created in the previous step, to find similar movies, return those similar movies along with the score, and then we're going to create an array of movie result objects, which we then return. So let's see how this works. Here we have our query field, find similar movies, and we can see here how the types that we've defined and the signature of our function is used when the GraphQL schema is generated in Modus. You can see our return type is an array of movie results, and that's inferred from the classes that we defined in assembly script, which is pretty cool. So let's see, Band of Brothers is one of the movies that we generate embeddings for. So let's find 10 similar movies. And we can see here, I'll take off the embedding field. We don't need to return that. We can see here the first result is Band of Brothers, which has almost a perfect score. So that makes sense. We have movies like Saving Private Ryan, Generation Kill. So these are sort of spy or war movies. Cosmos, I think, was also on that list. So Cosmos, Interstellar, Black Mirror, Lord of the Rings. So somewhat, I think, relevant results there. Cool. So in the interest of time, let's
All epic,
move on.
epic things.
But this, yeah, exactly. This hopefully is a useful resource for getting started for the hackathon. I'm going to also add a Next.js front end so you can see how like Apollo clients queries work for that sort of thing. But this code will be in our Modus recipes GitHub repository, which has lots of code samples and those sorts of things. So I will share a link to that in the chat. And that's where you can find the code. Again, once it has the front end, it'll be sort of like a starter kit for the hackathon. So hopefully that is useful. I'm going to switch over now to Raphael, who's going to walk us through an example of using Dgraph with Modus.
Yes, perfect, and thank you, William. So we'll use the same ingredients, but maybe in a new recipe. That's interesting to see how we can mix things, and we'll change also the graph and use Dgraph. And every graph is interesting. You know, they are a good graph for traversal, for some for queries, some for also a property graph. So it depends on how you want to use that and your use case. You have to explore a bit, and it's not a big landscape, but it's a very interesting one. So we will do RAG with graph. So you've seen this terminology. So to me, and so it's about generating a content. It could be a text, an image, or whatever, but from a model, but using data that we retrieve from the graph. And the data that we retrieve from the graph, it could be, as Michael said it could be used for the context or the prompting, but it could be also used by the function tooling. So the more agentic approach, when you the model will decide to say, oh, I don't have enough information myself in the memory of the model, so I need to use a tool, and the tool could use the graph, and then we can start to use very interesting things. So that's what we can build also with Modus and a graph database here, is to have this notion of chat getting information from the LLM. Maybe the context could be created by the graph itself, and the function calling certainly can use the graph, and so on. So in terms of what we will put in the graph, so I also follow the GraphRAG patterns that are interesting, and you will see more contribution on how to implement with Dgraph, and there are lots of implementation with Neo at the moment. So it's interesting, I think, to see options there, and it's really interesting to organize the knowledge as those patterns language here. So in terms of graph, we can have everything you know in the graph itself. So it could be your knowledge, your domain graph, or it could be a lexical graph. So the knowledge is somewhere else. In our case, for example, in an MD files or MD files. And we want to use the graph to basically put a structure on that. So to break it into parts and to put entities, relations, and extracting things. And basically, it's another view of the same data. And a third one we can use is when you have siloed data into your company and you want to see that as a connected things, but you don't want to move the data. So you can create a virtual graph that will be references and maybe have some metadata or description, and you can work from there. And as soon as you want to get more details, you go into the where the data is. And in terms of, you already started to introduce, Michael, this concept. So I will use the knowledge into a markdown file. I will use a lexical graph with a hierarchical structure, and I will use an approach of parent-child retriever with tree merging. So I'll explain that in a moment. So the implementation is simple. I have a document. The document is, I call it a page, and it has a root section, and this section contains other sections. So with this, you can do header 1. Header 1 contains header 2, contains header 3, whatever. And every section is divided by chunks of text. So you can control the length of the chunks. So let's go into a bit of the what we want to achieve there. I will start with, so everything will be in Modus recipe too. I saw that Matthew is on the call. I stole a few things from Matthew for the make file, so you can start the Docker image, you can upload the schema, and it should be easy to use thanks to Matthew's work on lots of projects with Dgraph. So I'll not dig into those details. I wanted to show you the extra folders. There is a document there. So you see the document, for example, is about the solar system. And so it's not a huge document, but it has lots of information. And you see there is a header with the sun, overview, key facts, is a subheader, and different things there. So why chunking things is, first, it's interesting to see that what you will provide to the LLM, your context, it's better to have a short context that is right to the point. So it's improving the context, and it will help the LLM. Instead of digging into this big text, it will go to exactly the information that you need. Second, it's also cheaper because you have to pay by token. So if you can reduce the context, it's good. And it's also faster because you don't have to load, 2 megabytes of data, and you get only the context. So trying to find the context when you ask a question is interesting, and it's definitely something you have to do for a real case implementation. So how it looks like, and then I will dig into the details. So you see the document, it's uploaded, but I'll show you if we have time. But you can say which planet, for example, has rings, and we'll see, we can do some random things. And so what the response is Saturn's, and it's a renode for a ring system. But what is interesting, the UI is also in the repository. I prompted which document was used, and the extract of the document. So you've seen the document is big, but what I sent to the LLM is only this part. It's the overview and the subsystem. But if I ask, for example, what is the difference between Neptune and Saturn, I don't know if the question is really interesting, but let's see what. So apart from the response and saying the composition is different, and one is giant and something is more similar to Jupiter, the interesting thing is it found the information from info, the same file, but you see this time I have different chunks for different parts of the text. I have one which was the subheader of Neptune and the description of Neptune, the other one from Saturn, and it has been aggregated, I have the sub-document, and used as the context. So we have here a very good context to provide to the LLM that has been extracted from the document. So how we do that, basically, let's go into some of the details here. We can see I've used exactly the same ingredients that William showed you. I have Modus dev running there. And if we go to the Modus Explorer, we'll see that I've exposed a bunch of services, just also to test them. But the main one is the split, adding a markdown file, and it's splitted. There is a rank document, and from the rank document, we can get a context, and from the context, we can ask questions. So the only one I'm using for the chatbot is generate a response from a doc, but we can go into details of how it's done there. So first, in terms of schema, so Dgraph is a bit different in terms of the schema. You don't really have to define a schema. You can just define the predicates. So the main thing here is that I have chunks. So nodes could be chunks, and that they have the content. But you see that a chunk vector embedding is a float 32 vector. So as Michael explained, we have to store a vector for the embeddings, and we just declare the index. The index is the HNSW index, so it could really handle very large volumes of embeddings, and that will be also implemented directly with similar function into Dgraph. So you can declare as many as embeddings that you need in one node. So you have an embedding for the description, an embedding for maybe attributes or whatever. So that's also pretty powerful here, because I don't really have to do much so I just upload that, and I'm ready to do some mutations and save elements. So when you see the index TS file there are a few things from the RAG script. So I also use assembly script. As William said, we use assembly script instead of JavaScript because behind the scene we are using Wasm as a powerful tools to get serverless functions. And so there is a good match with assembly script in Wasm here. So when you see the add page, add markdown page, for example, what we do is we remove the page if it's there, and we add the page to Dgraph. So how to do add the page to Dgraph? You will see that I do a splitting of this document, and then I compute the embeddings. So like William said, and I'm doing a mutation in Dgraph. One of the differences is if you see mutate doc in Dgraph, you will see that I have the doc page structure. And what I'm doing is a mutation, and you will tell me, it's only 3 lines, where is my query? So that's one of the beauty also Dgraph. In this case, I don't need a query because we handle JSON natively. So I just have to declare my structure correctly in my code, and I put the JSON and done. So Dgraph, we handle that as nodes and relations. So the nested JSON would be translated into relation, so I don't have to learn a query language in this case. I will have to do some queries when I will try to find similar things. But you see, for example, I will find a similar chunk with vector embeddings, and then I will find all the chunks matching this. So that's the kind of queries that you can write in dql, the Dgraph query language, and then you get the responses. On the Dgraph query language, it's a descriptive language, so that means you get what you ask. So the structure of the response is exactly the structure of your query, so you don't have to deal with handling records and attributes. The mapping is also natural, so you can get that and map that to a class. So when you see how I use that, you see doc page is a class, and you will see that I'm just putting some names to map that to the name into into Dgraph. It's my decision here, design decisions to have, for example, chunk section level instead of level. So I'm just mapping the names. But as soon as it is declared, then I can use JSON as input and output effectively. So I wanted to go just into another one, which is when I do the add page, I need to split into markdown page. So what I'm doing here, we have a recursive character splitter. So I'm using the character splitter with the markdown for headers. And I also split by lines with the max words. So I'm counting words instead of characters. If you know this splitter from a Python library, usually they use characters, but I don't think it's interesting for LLMs. And that's it. And when I have those chunks, I can just add some code to create my JSON structure and mutate that back to Dgraph. So when I add the document to Dgraph, so you can use the Python script here. There is some tooling to load the data. And basically, it's doing a mutation, add markdown page, and with the documents that you have, and that's it. And if we go to Dgraph itself and we do, I hope we have a query here. Yes. You'll see, for example, my documentation. So I have one document here. The document is the one about the solar system, but you will see that it has a section, and the section has chunks, and the chunks, they have the content. So you see the content here, Venice, for example, but this one has a subsection, the subsection has a subsection, and it has chunks with the data. So when we will find the similar chunk, we find, for example, 3 of them in different places, then we can aggregate the content and use that into the LLM. And that's what we will do into the chat function here, which is there into the index. And when you get a response from documentation, generate response from documentation, then you will see that I have a text. I can compute the embedding of this. I get the RAG context from the question, which will return only the extract of the document that is interesting for the question. And then I will use a LLM to generate a response. So when I do the get RAG context, I'm doing a ranking, and I did. So the get RAG context is get a matching sub pages and then rebuilding the document. And to do the matching, it's very simple too. I have a ranking system on the chunks with a limit and a threshold, and you can test this ranking here. And you see it's a rank by similarity on Dgraph with a limit on a namespace, and the rank by similarity is a small function saying get the similar functions, compute a score. So I'm using a dot product score here, and because the vectors are normalized, so we can do that, and it's effective. And then I can order by similarity score and take the first one. I think we are nearly on the time. So the best thing is I will do a recording of the details, because you can launch the Dgraph Docker image from this project, and you can load the data, and then you can play. The UI is also there. So the best thing will be to publish a video, to publish the code, and you can dig into the details and also contribute. If you want to improve the splitter or do different options there, you're happy to get this done. And I think that's what I wanted to share in terms of how to use the the chunking of the text, the storage into a graph, the ability to do a recurse queries, because it's very effective to do this, finding the chunks, going up into the tree, and from the document get all this context. It's not that easy to do when you store those chunks into different tables, and you want to understand the hierarchy into your tables, and you usually end up by reference and recursive calls into the same database. Here it's one single query in Dgraph, and Dgraph is doing this for you. So I think it's a very interesting usage of the power of the graph for the retrieving context for LLMs.
Cool. Well, thanks for that, Raphael. That's super interesting. Hopefully, these 2 examples will be useful resources for folks getting started with the hackathon. Like Raphael said, the code for both of these projects that we showed, both the Neo4j movie starter kit and Raf's example working with Markdown RAG in Dgraph, will be available in the Modus recipes GitHub repository, which we've linked in the chat. Be sure to sign up for the hackathon, which I've linked here as well. So I see a few comments in the chat. So Manish says, thank you. Really interesting to explore knowledge graphs and AI, digging in more. Cool. Thanks a lot, Manish, for joining today. We have a couple of questions, which maybe we can go through just really quickly here. So I have one question asking about different types of PDF files, how to connect them and find the relationships from different types of PDF. So this would be going through, something like entity extraction, and then finding relationships between those entities extracted from the PDFs, not just in one PDF, but across multiple files. Michael or Raf, do you have any pointers you'd like to mention for this workflow?
Yes, for the different. So it's one of the approach when I talk about the virtual graph. Of course, one PDF is not aware of what is in the second PDF, but as soon as you chunk that and you put them in the graph, then you start to connect to something else. So it's up to you to design. So when you load your first, in my example, I just created chunk about the PDF, but you can see an extension of that Michael was talking about is creating entities, saying, oh, what's this document is about? So now I will create a subject. And then the second PDF will also connect it to the same subject. And now we have the graph connecting the two PDFs because they are talking about the same thing. So that's basically by the design of the graph, how you extract things and how you will connect the dots. Yes.
Exactly. Yeah. So you can connect documents through entities, but then also as you extract more and more entities, you can also extract entities and also relationships. So you can also basically surface the knowledge on the entities and the relationships that are hidden in the documents and turn it into knowledge graph. And then it's up to you if you want to retain the documents and the chunks or not. So that's also something that's really interesting. And especially if you already have an existing knowledge graph, then of course you can connect the entities that you have already in your knowledge graph to the chunk documents from your PDFs as well. So that's basically then an enrichment where your existing data drives actually the extraction and not vice versa. That's also an option here. And as Raphael said, as you put these entities in the graph can help you to do entity resolution as well. So you can deduplicate entities using the graph. And looking at the context, kind of who are these entities related to, and then use the graph to deduplicate them, or on top of that also vector distance or text distance, edit distance, and other things for entity resolution.
And that's also the beauty, just talking about it, I just thought, as we have the chunks, and we can find also similar chunk into another document. And then you can maybe think about, oh, I will measure how many of the chunks are similar. So maybe I start to see, two documents and how far or how close they are, or whatever the use case you have in mind. But that's
exactly. You can aggregate over the chunk similarity across all the chunks of a document, and then you can basically do an average or mean or something like that of the chunk similarity across the documents, and that's kind of created in document similarity as well. Or as Raphael showed, you can also do it on the different levels of the hierarchy, right? So you can also do it on the section level or on the leaf level as well. And actually, if you want to, you can even materialize it as in relationships in the graph as well. So you have an KNN graph then that you can use to navigate these networks as well, or run graph algorithms on top of them then. Which is the next level. We can talk about this.
Maybe the next topic it will be graph algorithm.
For sure. That would be super interesting. I know we're over time, so maybe we'll just take one more question. This will be our last one, and then we'll call it a day. So Anton's asking, very much related to what we were just chatting about. Do you have best practices for splitting documents into chunks to vector them for further searching?
Yep. And do you want to take it, Michael? Or?
So I think Raphael, you already had a really good point, right? So if you have an existing document structure, definitely make use of this existing document structure, right? So it doesn't help a lot to brute force cut a document into same size chunks if you already have sections or subsections or paragraphs and things like that, because there are semantic units in your document already, and you want to do a chunking where like semantic coherence inside of the chunk is really high, right? So it's a one vector embedding represents kind of what's the meaning of this, let's say, paragraph or a sentence or so, right? But between chunks, you want to have actually difference of meaning and essence as such, right? So if you have natural boundaries in your documents that already have this, then it's good and you should use it. If not, then there's a number of techniques from fixed size chunking to recursive chunking with overlap to even doing something more compute intensive where you actually compute the vector similarities between subsequent sentences, and you start to introduce a new boundary or chunk boundary when the two following sentences have a too high distance from each other as well, right? So that's semantic chunking as well. So there's a number of approaches there, but if your document has a natural structure like Raphael showed, then please make use of that. That's usually the better approach.
And you could see in the code that I've used some best practice here, saying first I'm using words, because to me, if you say 3 words, it's not really interesting. So, or counting characters. Second, the natural boundaries or the lines, because I want to keep a line complete, because the meaning is in the sentence. So boundaries of sentences. So try to preserve that as much as you can. So that's what we've done there. Yeah, exactly. And then the chunks, you have also to play with your embedding, because you have models that have, they can do large embeddings or are good at short text. So it's also depending on what you're using. But for example, what I've done has a pretty good result using the mini LM L6 V2, which is very cheap. For Hypermode, it's hosted by Hypermode, so you can get that for free with your account. So yes, you have to play maybe with different embeddings models and trying to find the right size that you want to embed.
Cool. Well, thanks for that. Well, thank you, everyone, for joining us today for this edition of Hypermode Live. And thanks to our special guests today, Michael from Neo4j and Raphael from Hypermode. It was great to do this. This was super fun. We'll definitely share the recording. I'll also put a link in the description to our live stream calendar so you can find these coming up. But hopefully, everyone is interested in the hackathon. Hopefully we showed some interesting resources for the hackathon. So hope to see you in the hackathon. I see some new folks have already signed up for that while we've been talking here. So that's great.
Well, yeah, looking forward to the contributions. And hackathons are always great because people are so creative and you see so many really cool ideas coming out of that. And so I'm really looking forward to everyone's ideas and projects, and can't wait to see what's coming there.
For sure. Great. Well, thanks a lot, everyone.
Cool.
And we'll see you next time, or we'll see you in Discord.
Yeah.
Cheers.
See you around.
Bye-bye.
Bye.